This is 4 milliamps. $3K. $4K. And I had a 9 here and a 3K. And the question for that was, what is I sub O? That's the current going there. Now, what some of you did source transformation here, but when you do source transformation, without showing any names, let me see if I can find somebody. Yep, there's one, no name on it, good. When you do source transformation, I sub O is not this current, I sub O is that current. Because if it's this, it's 1 milliamp, whatever that value there. But it's not. It's that current going to that 12 and the split there. So now you can't do current division either because you don't know what the rest of the circuit is. So a lot of people say, oh, this is I sub O is right there. I did my source transformation. I'm done with it. One line that was done. No. So let's see what we're going to do then. And they want us to use, and the problem it says, find I sub O on the network using source transformation. Well, I can do source transformation on the top piece here. I can do source transformation on that one. Now first I can take these two resistors, combine them into what? 12. So I have 12 in parallel with 4, right? So what is 12 in parallel with 4? That's what that means, in parallel with 4. That'll be 12 times 4 divided by what? 4 and 12, 16, and that's 3K. So these three resistors combine here, these three combine will be equivalent to 3K. So I can take the circuit now, 6 volts, 6K, 12K, and here is that 3K now, again, which is the equivalent of these three coming down, and now we have that source with that. Now you can do source transformation here, put 3K here, and that source, notice it's going this way, it'll be minus to plus, and the value of that should be what? 4 times 3, which is 12 volts. This is I sub O. I don't want to lose it. Three and 3 is what? 6? So I can redraw that and put the source on the bottom. I like it on the bottom here. 12 volts. 6K. 12K. 6K. 6 volts. Can I do one more source transformation right here? If I do one more source transformation there, this will be 12 divided by 6, which is what? A current going up of 2 milliamp. In parallel with 6K, 12K, 6K, 6 volts. I sub O again. $6K and $12K in parallel. That's 6 times 12 divided by what? The sum of them, which is what? 18. Is that a 4K? Almost done with it. So my circuit looks like this. 2 milliamp, 4K, 6K, 6 volts. And I can do one more source transformation. I sub O again, going in. I don't want to lose sight of it. One more source transformation, 2 times 4, which is what? 8 volts. This will be 4, 6, plus or minus what? 6. And now just do one equation, one loop. If you define I sub O as that way, negative 6 plus 6K I sub O plus 4K I sub O plus the 8 volts is equal to 0. 10K I sub O equals what? Negative 2. What's I sub O equals? Negative 2 over 10K, which is what? Negative 0.2 milliamp. One loop, one circuit. Again, the common mistake, people, once they do the source transformation here, they assume the current is that current there. Boom, you out. That was question 1 on the test. Source transformation. Let's look at question 2. I'll snap these later too. Put the solution up there online. Question 2. Use loop analysis to calculate the power supplied to 20 volt or by the 20 volt source. So here's my circuit. 5, 5, 10, all these ohms, not K's. There's a source here, 20 volts. And notice I was specific what method to use. I want certain method to be used because I want to make sure you know all the methods, which some of you ignored completely because you get used to one method. That's the one you feel comfortable with, and that's what you want to use. And I picked that method intentionally, use loop analysis. That means KVLs. And the reason I chose this, because it will make it 2 equations by 2 unknowns. You know, if this is my ground, you know what this voltage is. That's what?
Negative 20.
Oh, and loop analysis, I'm sorry. Yep, loop analysis. Node will be the best choice here because you know what the voltage there. You have 1, 2, and that's it. But I did loop analysis for that one. I thought it was his nodal analysis. So let's assign current each one. Let's call this current I sub 1. This current I sub 2. This current I sub 3. I'm going to have 3 equations by 3 unknowns. You have 3 currents. And the question, what is the power delivered by the 20 volt source? Now, if my current is positive here, I sub 3, that means it was supplied because you have positive current entering that node, right? So hopefully my current for this is negative. Because if it comes from this end, that means entering a negative that's been supplied. And the question, what is the power supplied by the 20 volt voltage source? So they give me a little hint that the current, this is going to be supplying power. That means that current will be going upward. I could change it if you want to make it supplying. Remember, if you have a positive current entering that negative end, the power is being supplied. So my gut feeling now tells me that current is actually going to go in that direction. I could have left it the other way, and I bet you my calculation will say it's a negative number. But if I switch the direction, it's going to be a positive number. So that will be 20 times I sub 3 if I sub 3 is positive. So I'm leaving it like this. Let's see if I sub 3 is positive. So here's a hint. I sub 3 better be greater than 0. Can't be negative for it to be supplying power. So I need 3 equations. I can go the top one, which is 5 I sub 1, plus I'm traveling this way, it's going to mark this plus to minus 10 times. What's the current going that way? The way I drew my currents, I sub 1 plus I sub 3. See, they're both pointing in that direction, pushing. Keep going, it's going to mark it plus to minus. This is what? 5 times I sub 1 minus I sub 2. What do we have? 20, 5, 10, and 5 is 20 I sub 1. Negative 5 I sub 2 plus what? 10 I sub 3 is equal to 0. Divide by 5. That's the first equation. I need a second equation. I can't use this. Why? The current source. We have no idea what the voltage here. I can't use this. Same thing. I can either go on the outside like this or go on this one. Really up to me. I'll go on the outside. Looks like less work in it. Yep. So let me travel this way. I'm going to travel this way. This will be what? Negative 20 plus, well, the current, notice I sub 1 is going this way, right? It's going to make it plus to minus, because I sub 1 is going that way. They're going to make it minus 5 I sub 1. I sub 2 is going this way. It's going to make it plus to minus, right? Minus 20 I sub 2 is equal to 0. Divide by 5 and move it there. This is negative I sub 1 minus what? 4 I sub 2 plus 0 I sub 3. There is no I sub 3, right? That becomes a 20 divided by 5. That's a 4. That's equation number 2. And what is equation number 3? I can use that source here. It's going upward. Both of these coming down, right? So the 2 amp equals, that's this current, equals minus I sub 2 minus I sub 3. They're both coming down. So let's go through that. 0 I sub 1 minus I sub 2 minus I sub 3 equals 2. That's my third equation. I should be able to go on my calculator there, 3 equations by 3 unknowns, and solve them. Here we go. 4, negative 1, 2, 0. Next equation. Minus 1, 4, 0, 4. The last one, 0, minus 1, minus 1, and 2. Solve. And if I typed in the right numbers,
did you do 4 or negative 4 in the second equation?
second equation here?
Yeah, you only said 4, but it should be a negative.
No, because you moved this to this side, right?
No, I mean 4 I sub 2.
Oh, I don't know. Let me just see. Let's try it again.
I obviously I don't know what you typed, but you only said
Yep, let's see. I probably did what I typed probably what I said. Let's try it again. 4 for the first one, minus 1, 2, 0, right? The second one, 4, minus 1. Oh, I was looking back there. Uh-oh. This will be what? Minus 1, negative 4, 0, 4. The last one, 0, negative 1, negative 1, 2. Solve it. I got I sub 3 to be negative 0.9. Should be positive if it's supplying. If it's supplying power, unless I goofed here, 5 I sub 1, 10 I sub 1 plus I sub 3, 5 I sub 1 minus I sub 2 equals 0, 20 I sub 1, 4, 1, 2. Good, that's good. This one, traveling this way, negative 20, negative 5 I sub 1 minus 20 I sub 2 equals to 0. Yep. Divide by 5, by 4, by 5, that's 1. And the last one, 2 amp should equal minus I sub 2 minus I sub 3. Hope I didn't push the wrong button. So on my calculator, I get the answer to I sub 1 to be 0.2105, I sub 2 to be negative 1.05, and I sub 3 equals, I get negative 947. That means I sub 3 is coming really down according to my picture. It should be, instead of supplying, absorbing power. So the power for the 20 volt source, it should be positive, which is taken according to my picture, my number here, 20 times 0.947. Sometimes if I just do it one step at a time, I'll be safer. 20 times 0.947, 19 watts. But it shows as 19 watts absorbed, not supplied. Did the question say supplied?
Yes.
And the answer is 19. They have positive 0.95. They have 0.21, negative 1.05, positive 0.95 for a solution. I got negative 0.95. That's according to the calculator. So it should be absorbed, not supplied. Their answer came up positive, so they assume it's actually, wait, let's see. Oh, they defined their current down, positive, so that's the same answer. Yep, they're wrong. Because they defined their current coming down. I sub 3 is coming down, see it? I don't know if you can see it. And their value is 0.95, which is fine. I defined mine going up, which is negative 0.95. So 0.95 times this, that's plus, entering a plus. That should be absorbed, not supplied. So that should have been here. So we were right, they were right. Actually, just they used the wrong word here. This is going to supply, that's going to absorb power. You're forcing the current to go back into it. No? Math is correct. It's just the word, the supplied, absorbed. Okay. I think you get that one right.
Yeah, okay.
Since then that's wrong, I gotta take some points away from you. That's question 2. Let's look question 3. I'm looking at it, and I already see like a higher end to it, so look, lower this. Five volts, 10K, 40K, 40K, 20K, and that's 80K. And the question here, find V out. I'm assuming V out is the last one. This one. I'm assuming that's what V out.
Oh, I think it was
We asked to find the V across the 40K.
the bottom right.
The bottom.
Oh, sorry. Yep. This is a V out. Because I was looking at the end, I didn't see it labeled. Guess what that means? This is V out. Because this voltage is the same as this. So V out is right there. This one is called Vx. Where is this attached to? What's this voltage here? 0. What's that voltage here? 0. Assign currents in any direction that you want. Let's do KCL at this node. This is 5 volts here. This current, which is what? 5 minus 0 over what? 10K, it's going in. So it's this minus that. Equals. Nothing is going this way. It's going to equal to this plus that. This current is going to be what? This voltage minus this one. Over what? 40K. Plus this current, which is this voltage minus this. Over 80K. What is the LCD? 80 here? So 8 times 5 is what? Is that 40? Negative 2V out minus Vx. That's one equation. KCL of this node. That's all I did. Now I have one equation by two unknowns. Now if you look at the circuit right here, what's this voltage here? Vx. There's no current going that way. So it's going to be voltage division. Because V out is going to be Vx times that resistor over the sum of them.
So you could have done this one like super.
That's it. V out is what? 2/3 Vx? Or Vx equals what? 1.5 V out? Plug it in now. 40 equals negative 2 V out minus Vx, which is 1.5 V out. 40 equals negative 3.5 V out. What is V out going to be? Negative 40 over 3.5. Negative 11.4. Done. If you don't like what I did here, do KCL at this node. Go, okay, There's current going this way and current coming down. There's nothing going that way. This current, Vx minus V out over 20K, equals V out minus 0 over 40K. And that'll give you that equation. If you don't like, because there's no current going that way, 0. No current coming out of it from that end. So this current and this current have to be the same. This has to equal to that. That's question number 3. Let's look at number 4. Use nodal analysis. Uh-oh. That looks like a big problem. That might have, let me start with the top, otherwise I'm going to start complaining about not enough space. 4 I sub x. Two, eight, 4, 10 amps, two Vx, and I'll find out where Vx is in a minute. This is 10. Five. I see the Vx. I'll label it in a minute. This is 20. This is 6 amps. Here's Vx. Vx is labeled like this. And I sub x is labeled, I really can't tell if it's going in, coming out. I think it's going this way, I think I sub x, but I can't tell from the picture. Yeah, it's hard to see. Yeah. It looks like it's going in, huh? It's going that way. I can see it pointing toward that one. Now, when you look at this initially, oh my goodness, there's a lot of equations by a lot of unknowns. Well, we know what that voltage is. That's what? 20. There goes one unknown. Use nodal analysis. So here we go. This is 20 volts. This one, I think they call that V1 here. Now me, I don't know why they call this V4, and this is V2 here. That's good. I won't call that V4 because they call that V3. They call that V4. This is a supernode. A voltage source is a supernode. So instead of calling that a V4, I'm going to call that what? V1 minus what? 4 I sub x. So how many voltages are known to us? V1 and V2. Let's define current in any direction that you want. Let's say I define current going this way, that way, this way, that way, this way. We have I sub x. Yep, that's good. Oh, I already have I sub x pointing in that direction, right? So let's call this I1, I2, 3, 4. KCL at V1. The current going to V1, what do we have going to it? The 10. What is leaving? I sub 1, I sub 2, I sub 3, that's a supernode, and I sub 4. This and this the same thing. Ten equals, what's I sub 1? V1 over 4.
Is that times I sub? No, it should be plus I sub 3.
Plus. Everything's plus, yep. Plus I sub 2. What's I sub 2? It's V1 minus V2 over 8. Plus I sub 3, that's this one. That's this minus that, so V1 minus 4 I sub x over, minus V2 over what, 2? And the last one, this one minus the 20, V1 minus 4 I sub x minus 20 over 5. Not nice, because my LCD now became what? 40? 40 times 10 is 400. 10 V1 plus 8 V1 minus 8 V2. 5, yeah. Divide by 8 is 5. This will be 20. 20 times 4, 80. 20 V2. This will be 8, right? 8 V1. 8 times 4 is 32 I sub x. Minus 8 times 20, is that 160?
You add 160 to the other side.
Yep. So if we add 160 to both sides, we'll have what? 560? 10, 15, 35, I think so far. 35 and 8, 43. Let's look at V2s. Negative 5, negative 25. Any more? Let's look at I sub x. I see the 80 here and the 32. Is that 112? And that's the first equation with 3 unknown. That's 1. I need to get another one. Maybe I'll do 1 KCL at V2 here. KCL at V2. The current in 2Vx. Another variable now. Going in. Plus what? I sub 2 plus I sub x plus I sub 3 equals to 0. Nothing leaving, the way I define them. Where's Vx? What's Vx equal to? This voltage here. Isn't that this voltage minus that voltage? That's what Vx. Vx, it's this end minus that end. So Vx equals V1 minus 4 I sub x. Take away from it what? 20. So if I plug it in here, twice that number, that'll be what? 2V1 minus what? 8 I sub x minus 40. That's what this one is. What's I sub 2?
What is that?
I sub 2, where is I sub 2? Right here. V1 minus V2 over 8. Notice my equation has V1, V2, and I sub x in it. So let's leave it. So V1, V2, let's leave I sub x as I sub x for now. And let's have I sub 3. What's I sub 3? V1 minus 4 I sub x minus the V2 divided by 2 equals 0. LCD is 8. 8 times 2, 16 V1. 8 times 8, 64 I sub x. 8 times 4, 320. That'll be 4 V1 minus 16 I sub x minus 4 V2.
8 I sub x in the middle.
Oh yeah, thank you. 8. They multiply by the LCD. That's an 8 here. So the 320 goes to the right side, becomes positive 320. Let's look at V1. Any more? Is that 21? V2. Is that it? And the last one, I sub x. Negative 64 plus 8 minus 16. That's negative 8. Is that negative 72? I think I'm good here. That's my second equation. One equation, two equation. I need a third one with I sub x and V1, V2, whatever in it. Well, let's look at I sub x right here. I sub x is this current going in. So what is I sub x equal to? 20 minus V2 divided by what? 10? So multiply by 10. 10 I sub x equals 20 minus V2. Clean it. 0 V1, there's no V1, plus V2 plus 10 I sub x equals 20. And there's my three equations by three unknowns. I forgot what the question is. Solve for V1, V2, V3, and V4. Again, V3 is this one. That's 20. I don't even have to do any math to it. V4 is that one, which is once I know I sub x, V1, V2, I'm done. So let's type in the four equations into my calculator here. Simultaneous, here we go. Three equations. 43, negative 25, negative 112, 560, 21, negative 5, negative 72, 320, 0, 1, 10, 20. I got V1 to be 21.14, V2 to be 9.07, I sub x equals 1.09. So there's V1, there's V2. We know V4 is 20. That was the source. That was V4. V3 is that one. So what's V3? It's V1 minus 4 I sub x. V1 is what? 21.14 minus 4 times 1.09. .14 minus 4 times 1.09. $16.7, 9.07, 21. Oh, we got it right. Ooh.
I thought V3 was 20.
Before.
I think you.
Oh, label them backward? Yeah. Yeah, they labeled backward. This is, I guess, 3 and that's 4. Which one is this? This is 4? And that's 3 here? Okay. This one is the 20 and that's that one, whatever numbers they use, labels for them. And the last one, how we doing with video? Oh boy. It's going to be tough with the video. It's going to tell me it's too long. They still put it there, but they'll think me in concert. You know, sometimes it takes more than an hour, curtain calls and all the stuff. Find V out using Thevenin. This is 2I sub x. One K. You probably realize by now you really need one of those calculators for this class. Because if you were to solve these equations by hand, forget it. And this is V out. Two milliamp. I sub x, if my eyes are good, it's going in. So they want us to solve for V out using Thevenin. That means I got to Thevenize the circuit there. Notice my circuit has both independent and dependent. To find R Thevenin, I will need V open circuit and I short circuit. Let's do the V open circuit. I'm just redrawing the whole thing again. The only thing I'm leaving that piece out. That's the only thing I'm not doing. Oh, that's actually nice. What's the voltage here? Watch how quick.
You can do KVL around that little loop.
You don't have to do KVL here. No? Watch this. Where's that current going to go? It'll go this way, right? So this is going to mark it plus to minus. What is 2 milliamp times 1K? 2 volts. Yep. So if you put a source here, if you put a meter here, so this is my meter. Now one plus to minus. You do KVL here. What is that meter going to read? This is negative VOC plus, I'm going this way, plus 2 volts. That's this one. Minus the 12 volts equals 0. V open circuit equals what? Negative 10 volts. That current has nowhere to go but down that way. I'm done with the open circuit. Now we're going to put a short circuit here and see what will happen. Like that. So let's find I short circuit. And now we're going to put a short circuit right here. And what's this current I'm looking for? I short circuit. And this is, where was I sub x? I sub x is going that way. And we can use any method to find that. Well, looking at that picture, looking here at this node, if we do KCL at that node, here, it says the current in equals the current out. What's going to that node? The 2 milliamp plus what? I sub x should equal what? I short circuit. So if I know what I sub x is, I'm done. What's my voltage here? Here. 0. What's my voltage here? How about negative? What's my voltage here? Unknown, right? What's my voltage here? Unknown. So if I want to do KCL, I will have two equations by two unknowns. I can write current in any direction I want to. This becomes a supernode if I decide to do that. I'm looking, if I do mesh equation, it's still the same thing. Because I know that current, right? And this current will be negative 2 I sub x. It'll be 1 here. 3 equations by 3 unknowns. So it doesn't really matter what I use there. So let's use this one. KCL at V1. What's the current going to that? 2 I sub x. What's leaving? V1 minus ground over 1K. And what about this one? V1 minus negative 12. That makes it plus 12 over 1K. I just want to look at that one to see if that was in milliamp or not. It didn't say that's in milliamp, right? Oh, wait a minute. Oh my goodness. I didn't even have to do that. Watch this. I don't have to do that. I just realized. I could. Well, but why? I could. This is nothing wrong with it. I just took another look and I said, I sub x is this current, right? Going that way, which is what? Isn't that this voltage minus that voltage over the 1K? So what's I sub x? It's this voltage, negative 12, minus that voltage is what? 0 over 1K. And what do we get? Negative 12 milliamp. Done. I know I short circuit. I short circuit equals 2 milliamp plus negative 12 milliamp. which is what? Negative 10 milliamp. I don't think it was that easy, but it turned to be that easy. Now I know our Thevenin. V open circuit over I short circuit. What's my V open circuit? Where'd you go? Negative 10 over negative 10 milli, which is 1K. You don't like that, huh? Banging your head there.
So like, are you always looking for a better method, like all the time?
Well, sometimes you see them. Like honestly, I didn't see them first. I didn't see it first. I was about to do two equations by two unknowns and solve it. Then I flicked my head, came back, and I go, oh, wait a minute. I sub x is this. Like, oh, wait. So now my equivalent circuit for that is going to be my V open circuit, which is what? Negative 10 volts, or V Thevenin. This is the 1K. And this is the load resistor, which was what? I forgot. What was that resistor that we took out? It's 1K. And the question, what's V out? Voltage division, negative 10, 1K over 2K, negative 5 volts.